Welcome to Precision Micro, Europe's largest independent supplier of photo-etched components. Virtually all new cars, mobile phones and computer chips utilize components manufactured by Precision Micro to the highest standard. One of the manufacturing world's best-kept secrets, photo etching produces highly accurate, identical components for large and small-scale applications, from one-off designs to batches of 1 million or more. The photo etching process involves photosensitive polymer being applied to a raw metal sheet. Using CAD-designed photo tools as stencils, the metal is exposed to UV light to leave a design pattern, which is developed and etched from the metal sheet. The resultant component shape is then cleaned and sent to the finishing workshop for forming, surface treatment and inspection prior to dispatch. All business processes are streamlined using a bespoke computerized system which ensures that orders are accurately processed, data is efficiently managed and deadlines are met. The company's integrated vertical storage and retrieval technology ensures that a wide selection of materials are always on hand, so clients requiring a fast turnaround can rely on Precision Micro when production deadlines are tight. Precision Micro engineers are highly trained to work with a wide range of digital CAD design formats from which they plot front and rear component stencils known as photo tools. Accuracy is essential, so all photo tools are printed using state-of-the-art laser plotters with capabilities in microns, all in a monitored environment where temperature, humidity and cleanliness are tightly controlled. Precision Micro's photo tools are so cost-effective to produce in relation to traditional tooling that design revisions can be implemented at a fraction of the cost, allowing customers to perfect their designs without the usual budgetary constraints. Once a material has been selected for photo etching, it is imperative that it is thoroughly cleaned of all contaminants, allowing good surface conditions for etching. The photo etching process can be achieved through a number of different lamination methods, including roller, wet dip or dry lamination. This comprehensive range of approaches allows component manufacture from metal with thicknesses of 10 microns to 2 millimeters and in sheets of up to 1.5 meters in length. During the lamination process, it is important that contact between the photosensitive and metal layers is uninterrupted. So again, a tightly controlled clean environment is essential. The metal sheet is sandwiched between the photo tools before exposure to a burst of ultraviolet light, which hardens selected areas of the laminate into an acid-resistant surface. The sheet is developed and any unexposed laminate is washed clear. Acid solution is sprayed onto the sheet, dissolving the exposed areas of metal and revealing the product design. If the metal is exposed on only the front photo tool, then the acid will etch from only one side. And where both the front and rear photo tools contain etchable areas, the metal will be entirely removed, leaving smooth, burr-free edges without affecting any material properties. The remaining resist is then stripped away to reveal the finished item. The process often offers a natural solution to many design challenges. Components suitable for blood filtration with features finer than a human hair can be produced at the same cost as a simple cutout. And logos, part numbers and other special features can be incorporated at no extra cost. Precision Micro offer a wide range of technical finishes and plating to improve conductivity, impart insulation properties, or improve corrosion resistance, all of which are internally verified. Components can also be formed into complex three-dimensional designs. By etching a straight score mark, foldable edges can be formed for a variety of applications, including RFI shielding for electronic systems. Prior to dispatch, components are visually inspected as well as compared electronically to the original CAD designs. Used photo tools are stored in the film library ready for future requirements. And as they are highly resistant to operational wear and tear, the first component is identical to the last, no matter how many batches are produced. With 500 million components produced every year from over 1,000 tons of metal, Precision Micro have a proven track record in delivering excellence globally to thousands of satisfied customers. Precision Micro's highly trained engineers are expert in developing revolutionary production techniques to fulfill any engineering requirement at a fraction of the cost of traditional methods. To discuss how Precision Micro can fulfill your component manufacturing requirements, email info@precisionmicro.com or visit the website www.precisionmicro.com for further information and local contacts. Precision Micro, engineering with imagination.
Under electropolishing here at KEPCO, we have pre-cleaning tanks that are set up primarily if parts need to come in and be degreased. We use an alkaline solution and degrease the parts prior to electropolishing. If the parts have weldment scale in them, we also use a deoxidizer, and what that does is loosen up the weldment scale and helps prep the parts prior to electropolishing. We use here a power washing system in which we use deionized water with 1 million ohms medical grade to free the weldments from the actual parts prior to electropolishing. During the electropolishing process, it's important to understand that there's a DC current that runs through the parts in order to accomplish electropolishing. Electropolishing is basically reverse plating, in which happens we have to hook up the part or piece onto a cathode and run it in the tanks next to the screens which act as the anodes. During that process is when electropolishing occurs and tiny amounts of metal are being removed. Also, behind me we use post-cleaning. After electropolishing, we post-clean using nitric solution or citric solution, depending on the type of metal, because of the metal salts that are left on the parts after electropolishing.
ECM is an advanced, extremely accurate metalworking technique based on electrolysis. ECM, electrochemical machining. Through the use of electricity and chemistry, metal is machined in a non-conventional manner, in which the metal is quickly and accurately eroded to produce the desired three-dimensional end product. We call the tool that is used to machine a product via ECM an electrode, or cathode. This electrode has the inverse form of the desired end product, and does not wear during the process. The material used for the electrode does not have to be harder than the workpiece either, because it makes no contact with the workpiece, electrically or mechanically. The metal workpiece in its raw form is eroded via an electrochemical process to achieve the desired end product. To illustrate the process, we show a cross-section of the process at the point where the process gap, and therefore the resistance, is lowest, causing the material to dissolve anodically. In the process gap, which locally is smaller than 10 micrometers, the metal on the anode or the workpiece will dissolve quickly and accurately. The released electrons will be used at the cathode for the corresponding reaction. This corresponding reaction may consist of splitting water into hydrogen gas and hydroxyl ions. The dissolved metal ions can combine with these hydroxyl ions to form metal hydroxide. These reaction products, metal ions, metal hydroxides, hydrogen gas and heat, are transferred by the electrolyte at a speed varying between 15 and 50 meters per second. The electrolyte can be reused indefinitely due to the use of high-quality filtration and cleansing techniques. Electrochemical machining can be used to process virtually all metals and alloys. The speed of the process is not dependent on the hardness or toughness of the material, which means that exotic or hard alloys and hardened steel can be dissolved just as quickly as a soft material, like aluminium. The product features high accuracy and surface quality and is completely burr-free. The product is machined without any contact, so the product is not subjected to any mechanical stress. Nor is there any thermal stress on the product, so no heat-affected zone develops. Furthermore, there is no mechanical or thermal load on the tool, so there is no possibility of wear. ECM, electrochemical machining, an advanced metalworking technique that offers a solution for products that are difficult or impossible to produce through conventional techniques.
Making parts with highly detailed, extraordinarily tough shapes and tight tolerances can be nearly impossible with conventional machining techniques, but not with a wire EDM process. Imagine being able to make precise cuts in metal with a blade no thicker than a human hair. That's what wire EDM can do. EDM stands for electrical discharge machining. But instead of a blade like a bandsaw, wire EDM uses an electrically charged hair-thin wire to remove microscopic particles and shape the part. These animations help show how wire EDM works. The wire carries one side of the charge, conductive material carries the other side of the charge. And when the two get close, a white-hot electrical spark jumps the gap, melting away tiny dust particle-sized pieces of metal, 2 microns or smaller. How small is a micron? Well, if this was the diameter of a human hair, this would be a micron. But what's all this liquid? Well, that's the dielectric. Deionized water, really, useful because it doesn't conduct electricity. In wire EDM, the liquid dielectric controls the sparking, cools the process, and flushes away those tiny particles as they're removed. All very fast, about 1 million sparks per second. The particles themselves are each about the size of a particle of smoke. In the right hands, wire EDM can be used to hold really tight tolerances, create incredibly complex shapes, work with difficult materials that may be extremely hard or soft, and if needed, make really small parts. There's even something called small hole EDM for working from the inside of the hole to the outside. All completely automated and CNC controlled. No human involvement. At Exact, wire EDM is all we do. We're very good at it, making us the perfect wire EDM partner to produce complex precision parts that often can't be made any other way. Like this. Looks like one part? It's really 2. And this springy thing is just one part. Want to see more? Watch more of our videos or call for an appointment. You've been watching how wire EDM works. At Exact, we'll make wire EDM work for you.
profitably cut complex shapes with tight tolerances, you need a machine tool that's versatile and dependable. Abrasive water jets from Flow International Corporation have become the machine tool of choice around the world because of their reliability, simplicity, and versatility. Abrasive water jets cut virtually any material up to 12 inches thick, including aluminum, titanium, stainless steel, glass, marble, and composites. Ultra-high pressure water, pressurized up to 60,000 pounds per square inch, is cool, so there's no heat affected zone. Abrasive water jets cut by erosion rather than friction or shearing, so edge quality is very good, and the raw material's structural integrity is maintained. Most secondary finishing and associated production costs are eliminated. Very accurate finished parts come right off your system. Lightweight abrasive water jets are controlled with advanced motion systems, so your productivity goes up because there are no costly and time-consuming tooling changes. Changes in the cutting path are easily made in minutes by clicking a mouse or typing on a keyboard. And Flow's precision control systems are the simplest on the market. Flowmaster, a PC-based software program developed specifically for abrasive water jets, enables you to cut exact shapes without any previous knowledge of CNC programming or water jet cutting. With Flowmaster, you can draw parts from scratch, import CAD files, or scan existing drawings. You simply select the material, thickness, and edge quality you want, and Flowmaster will set all the cutting parameters. It fully optimizes cutting speed and machining quality. Flowmaster will even cost out a job, so you can be assured of maximum profitability. And Flowmaster features remote operation, so you can change cutting parameters from the shop floor. Metal powders used for parts production can be a combination of various elemental particles or pre-alloyed powder. If elemental powder is used, each of the ingredients that will comprise the desired part are mixed in proper proportion into a uniform blend. With pre-alloyed powder, the proper proportion of ingredients is already present in each particle. In either case, additives such as binders and lubricants are usually added. The powder is then consolidated in molds or dies, shaping and densifying it into a compact of the desired part. At this point, the part, or compact, is in a green state, where the powder particles are just lightly joined together. In this state, the parts have a so-called green strength, which is usually only sufficient for handling purposes. The parts are then transferred to a sintering furnace. During sintering, parts are heated at a temperature below the melting point or range of the base metal, but high enough to metallurgically bond the individual particles. Sintering further densifies the parts, increasing strength. Final part density is extremely important. Although controlled porosity is required and achievable for certain parts, the performance of structural parts increases directly with increasing density.
Let's take a closer look at the compacting process. For the better you understand the mechanics of how PM parts are made, the better you will be able to take advantage of the benefits of this well-established manufacturing process. Typical compacting techniques use rigid dies set into special mechanical or hydraulic presses. Tool sets are made of either hardened steel and/or carbides. there is a die body or mold. And for simple geometries, at least one upper and lower punch. And in some cases, one or more core rods, which will produce the designed-in holes if required. The die receives a charge of blended powder. The fill ratio of loose powder is around 2.5 to 1. This is delivered to the cavity by a feeder shoe. The upper and lower punches compress the powder. The upper punch is withdrawn, and the lower punch ejects the pressed compact. The feeder shoe, or transfer mechanism, takes the piece away from the die cavity. Then the feeder shoe refills the cavity with another charge of powder, and the cycle repeats automatically.
You learn about the basic trigonometry functions. You work with a lot with spheres. Basic programming teaches you the basics like the G codes, the M codes.
I'm a tool maker. I program using CAM software. I prototype parts and assemblies, test fixtures. CAM software is computer-aided manufacturing. That software is used in conjunction with a CAD-created drawing to make tool paths to machine a part.
A machine is basically a gigantic computer. You tell it what to do, where to go, and it does it.
I think it's an art form. Take a chunk of metal or plastic and to create something, to have something functional come out of that. To me, it's exciting.
I really enjoy it. It's fun.